First of all, thank you for Strusoft to giving me opportunity to speak in your event. My name is Tarmo Itarand. I'm a CEO of PCC Project. And first, I will couple of words about our company. Some of you know us, some of you maybe not. PCC is a structural engineering company established in 2002. The company was established by 4 structural engineers. We are located in Tallinn. And currently we have about 30 engineers in our staff, and we have been collaborating with Strusoft since 2005. Our main business is structural engineering, and since the founders of the company came from the prefabricated concrete business, then a big part of our business has been also a prefabricated concrete. That is designing prefabricated concrete structures and then doing also shop drawings of elements. And we are also doing quite a lot of steel structures. And more and more, a bigger part of our business is sort of this consulting type of business where we do preliminary design, give some expert opinions, assess structures, and also do some product development. For example, if a precast company wants to come to the market with some new products, and they need like engineering support, then we could offer also this kind of support. Big part of our business has been in the Scandinavia over the past 10 years. Since the Stockholm housing market crisis followed by this COVID, we have shifted our attention more to the Estonian market, and today it's about 50-50. And in Estonia, we are doing at the moment 1 hotel building in Pärnu Maantee in Tallinn. Then we are doing a couple of apartment buildings in this Volta quarters in north of Tallinn that has been on the news. And also we are doing this design of the Rae State Secondary School and sports facilities. And some of you who would like to join our team, then I would like to point out that we are a family-friendly employer, and we won the best internship company title last year in the category of small businesses. And we are also proud members of Estonian Association of Consulting Engineers and International Federation of Concrete, FIB. And now I will walk you through the projects that we have designed over the years with the help of Strusoft software. And in the end, I will show a little bit more closely some of the recent projects that we have done. First one is a residential building in Stockholm. Our customer was Abetong, and it was about 15,000 square meters, and was finished 2015. Then we have a library building in Göteborg. This actually was a renovation project. There was a small extension to it and the new facades around it. And here were quite complicated sort of balcony-like elements that later on the site there were brick columns laid on top of them. And here our customer was UPB from Latvia. Another project in Stockholm, Quality Hotel Globe. It is next to the Globen and the Tele2 Arena, and nice hotel building. Our customer was also Latvian company Skonto Prefab in this case. Here is a big apartment complex, I would say, in the middle of Stockholm, Liljeholmen, about 25,000 square meters, and we designed all the prefabricated structures here. Plus, we did the overall stability analysis with the help of FEM design, 3D structure, and yeah, there were all kinds of concrete elements, starting with the sandwich walls and ending with the filigrane slabs and double walls. Hospital building for New Karolinska. And here is a hotel and conference center in Helsingborg. This was a really complicated project. No straight columns, no straight angles, no straight nothing. And this was the project where we successfully used the Revit to FEM design link, because the engineer who did the stability and overall analysis, he knew very well Revit and thought that he can do the model much quicker in Revit, and he did, and then he successfully imported into the FEM design and calculated it. Here the concrete parts were designed with the screws of the impact, the hotel part and also the concrete part in this conference facility. And here I have to say that the steel was designed by the competitive software competitor. And here you can see this picture when this was in process of construction. Here is some office building also in Stockholm near Globen. Here you can see that we have done some analysis in the FEM design for the walls, and this was elements were designed with impact. And here is the picture of the finished building. Some parking structure. Also, you can see here a FEM design model. Everything is in. And here is the finished structure. Quite big apartment complex again in Stockholm, analyzed in FEM design 3D structure. Also, you can see some architect model and the finished building afterwards. Some smaller student apartments. Also some smaller apartment building, and once again one parking structure in Malmö, Sweden. And now I will come to the more recent project. This has been the biggest project last year that we have had. It is called Tallinn School of Music and Ballet. It is located in the middle of Tallinn, and I'm going to tell a little bit more about this project. First of all, this project actually has been going on for a long time. In 2011, Austrian architect Thomas Bucher won the architectural competition, and it has been in the design ever since. All those nice renderings that you see here are gratitude of the architects. And we started this project in December 2019, when the tender for the main contractors came out. We started right away helping Merko Ehitus Eesti to put together the tender. And when the Merko got the awarded the contract in February 2020. Then we right away started the design of this building. As I said, architect is Thomas Bucher from Austria. Our customer is Merko Ehitus Eesti. There is 5 floors of this building. One is completely underground, 4 are above the ground, and the area is about 24,000 square meters, which is quite a big building for Tallinn. Construction is in process at the moment. This design is almost finished. I saw that there are listeners from other countries. I don't know how it is in these countries, but in Estonia, the structural engineers who participate in projects, they are not very often recognized, and maybe not at all even. So I would like to use this opportunity that I have some audience, and I would like to thank the team who has worked their butts off for over a year to put this project together. And here we go. Our engineering team was Tanel Kullamägi, Kalle Kiristaja, and Veiko Vill. Our modeling or BIM team was Ants Ratškov and Taavo Tinno. Our management team was Artur Tšapenko and Kaspar Laurimaa, and the team was actually much bigger. I am not going to read them all. These were the sort of key persons. And also we had in this project, we had a couple of sub-consultants, Sirkel and Mall, and the Inseneribüroo Kandev, who helped us. And also there was involved a sort of site consultant from the customer side, Siven, who did a small but significant part of the building. So to all of you, thank you very much. And you have done awesome work to put this design together. About the work we did, as I said, we participated right from the beginning when the tender for main contractors came out. We helped Merko to put together the tender, and then we did all structural engineering. We built a PEM model in Strusoft 3D structure, calculated the whole structure. We optimized the foundations. Initially there were like 5 foundations designed, but actually we used Strusoft FEM, this relatively new soil model, and we were able to optimize the foundations. So we replaced the piles with a slab foundation. And also we removed some unnecessary dilatation joints, and also it was like designed like a double floor in the underground floor, so that if there are some leaks, they can gather the water between the floors, and everything will be dry. But we decided to remove the top floor, and we used some special additives for concrete to get the watertight concrete. So this was built actually with one slab instead of 2, and all much more simple. We did also complete sort of BIM model or documentation in this level of development 350. And what I mean by that is there is a small picture in the bottom explaining it, that we had all casting materials in. We didn't have a reinforcement for the prefabricated elements in, but we had the reinforcement in for the cast in situ part. And together with this team and sub consultants, we designed this complete building together with shop drawings. Challenges for this project. The biggest challenge was time schedule. Time schedule was very tight. When the main contractor got awarded the contract, they were eager to start digging and pouring concrete. And basically at that time, we started to redesign the foundations and doing all the general calculations. So it was a real challenge. The next big challenge is that there are a lot of specific acoustic requirements for the building, because this is a school of music. There must be all the classrooms and must be very well insulated from one another. So this made all the partition walls very heavy, and it was difficult for the slabs to be able to carry these loads. And also there were a couple of very unique solutions, like a deep beam or wall made of concrete with a span of 30 meters that carried three floor slabs and additional steel truss with a bit smaller span for the same reason that there is some hole under it and there can't be any columns or walls. This deep beam was calculated with a strut and tie model. Unfortunately, we couldn't use Strusoft software for this, but everything else is done with the Strusoft software. And here we can see also a picture of this 14 meters long steel truss in the building. For this BIM, we went for this impact hybrid solution. This means that we used impact Revit for modeling all the precast concrete, putting in all the casting materials and anchor bolts and etc. And we used the impact AutoCAD for shop drawings of precast concrete. Additionally, we used this plain Revit for cast in situ and general assembly drawings, and advanced steel we used for steel shop drawings. And why we decided to go with this impact hybrid is that first of all, it's cooperation with other parties, because nowadays everything is BIM, and Revit is this sort of this language that all the other participants can speak. And also, since this is a state project, there are state requirements for this BIM, and we try to follow them exactly as needed. And Revit gave us this possibility. We could not have done it with impact for AutoCAD, for example. We could make the model there, but the information that is needed is impossible to get there. And also one reason was that we have multiple materials in this building. As I said, cast in situ, we have prefab, we have steel, we have everything, and Revit can handle all these materials, so we could have one single model. And it's not all, it's also important that the Revit is a modern software, so we are trying to move towards this Revit as much as possible. And impact AutoCAD for shop drawings, it was very efficient way to produce the shop drawings, and we have plenty of skilled designers in-house available to do this job, and it would have been much more difficult, if not impossible, to do it in Revit all the way. Here are some examples of the wall element or wall element. That is, there are a lot of this kind of quite wall elements with kind of strange shape, and in the end there were practically no identical elements in the building. I think in the end there was one position that had two pieces. Otherwise, everything else was different. And this is the picture from the site this morning. This is how it looks like at the moment. They are starting the roof works on the left side, and they are still assembling a little bit on the right side, but it is getting the shape that it will be on the site as well. Then I have also another project I would quickly like to talk about. It is KV Lugnet Bromölla. It is in Sweden. We have a Swedish customer called Starka Betongelement, and it's an elderly home. And we decided with this customer that we will do a test project and try to do it all the way in Impact Revit. We started up, everything looked good, but in the end we fall back to this hybrid solution because there were some things still in this Revit for Impact that we couldn't do for the customer. This is a very special customer, and he has some things on the drawings have to be exactly like they want, and we couldn't do that with ease. We could have done that, but we felt that it will take too much time and effort. So we fell back to this hybrid solution where we do everything in the model in Revit, and afterwards produce the shop drawings with Impact AutoCAD. And looks like this model works very well at the moment. And to wrap this up. This is what this for us, what this impact design means in 2021. It's mostly about the data. It has always been driven about the data and the customer's need for the data. And nowadays everything is in the cloud. We have set up our own cloud where we can use our standards, and we have several customers where the cloud is in customer's place, and we are using their servers when we do the work. And what this actually means that collaboration gets much closer. The customer has always the latest data, and we have the latest data. For example, if we put one element ready for production, customer sees it immediately. If they plan their deliveries, we can see this planning data. We know if we can still make some changes or not, or is it in the pipeline to be produced. And we don't have to do. We can skip a lot of this boring work, making reports and exports and sending drawings, and they can access the data and drawings and whenever they need. And this cloud has actually enabled this remote work that we have going on for a year now. Because of this COVID-19 situation, everybody can work in the home if they like. And they can sync the files, and everything is running very well and quickly. And in this picture, you can. This is a picture from one home office at the moment. This is it. Thank you for listening, and I also would like to thank Taavo, Tanel, Ants, and Daniel, who helped me with this presentation. Thank you.
Fantastic presentation, Tarmo. Fantastic. Great stuff.